welcome back. Today we are reviewing our unit on factoring in preparation for the TSIA2 exam. All of the problems that are on this review will be relevant to ones that you are likely to see on the TSIA2 exam. There may be some differences between the item types, but overall the concepts that we go over on these questions will be used on one or two problems that you come across on that exam. Number 1 says, which of the following is equivalent to 24x plus 6? You can factor this out using the greatest common factor or GCF method that we talked about in the first lesson of this unit. But honestly, for questions like this, since they're multiple choice, I would recommend just checking each answer choice rather than working it out sort of the proper way. And what I mean by that is go ahead and multiply out each answer choice and just find out which one's the same. I think you'll find that the problems are going to be a little bit easier if you work them backwards like this. So let's start, choice A, obviously that is not the same thing. 30x is not the same as 24x plus 6. The 6 does not have an x on it. If it did, we could combine like terms, but since it doesn't, we can't. And so let's move on. Choice B, if we use the distributive property and multiply this 3 to both terms inside the set of parentheses, we would get 24x plus 6, which is the same. So that's probably going to be our answer. I'm going to circle it, but I'm not going to write it in until we check the other two answer choices. If I multiply the 3 using the distributive property on letter C, I'll get 24x plus 3 times 6, which is 18. Now that is not correct, so C is not going to work for us. And I think you probably can see where this is going. But 3 times 8x would be 24x. So far they all have that 24x except for A. But if I multiply 3 times 2x, I end up getting plus 6x, which is not the same as plus 6. So for number 1, our answer is B. Number 2, this asks, which of the following is not equivalent? So that means that 3 of these 4 answer choices should be the same if we multiply them out like we did in number 1. So I'll start by multiplying out the 2 using that distributive property to get 24y minus 24. All right, well, that's definitely not the same. So that is probably going to be our answer. But with this testing strategy, I highly encourage you to check all the answer choices just to make sure you didn't make a mistake somewhere. So we'll go through each answer choice and just verify that, yeah, they all equal 24y minus 12. If I distribute the 2 in answer choice B, I'll get 24y again. But for that constant, I get 2 times negative 6, which is negative 12. Yeah, and that is the same. So that kind of checks out. The question's asking which is not equivalent, so that is not going to be our answer. For choice C, we can distribute the 4, and if we do that, we're going to get 24y again. 4 times negative 3 is negative 12. Okay, so that is equivalent, meaning it's not the answer. And then choice D, if I multiply that 12, I'm going to get 24y minus 12 once again. So yeah, for sure our answer is A. Number 3, we will solve similarly. And you'll notice there are a couple of problems here which are going to be set up the same way. I just want to make sure that you have enough practice with these kinds of problems to where you can get these right every time. So let's start with that distributive property. And again, this one is asking which of the following is not equivalent. So we want to find the one that doesn't belong. So if I multiply 2 into that binomial, 2 times 42 would be, what would that be? I guess that'd be 84p minus 84. That is not equivalent. So yeah, we get lucky once again. Wasn't A the answer on the last one? Yeah, it's just the way it goes sometimes. But let's check the rest of these. So if I distribute the 6, and don't be afraid to use a calculator here. 6 times 14 is something you probably could do by hand, but you don't want to risk getting it wrong. Make sure you use the calculator when you have it available. 84p minus 6 times 7, which is 42. Okay, so that is not going to be our answer because that is equivalent to the given expression. If I distribute the 42 into this 2p minus 1 expression, 42 times 2 is 84. So once again, we get that 84p. 42 times negative 1 is negative 42. That is equivalent, which means that is not the answer. For choice D, we'll distribute that 2 in to get 84p one last time. And 2 times negative 21 is negative 42. So that is equivalent as well. So yeah, our answer is A. One last problem that is set up similarly. We're looking for an expression which is not equivalent to this one. So we need to multiply these one more time. If I multiply the 20 in, 20 times 2 is 40. So 40k minus 20, that is the same. So that is not going to be our answer. It looks like A is not going to be the answer every time. If I distribute 5 into the expression 8k minus 4, I'll get 40k, and then 5 times negative 4 is negative 20. Okay, so that's the same as well, so that's not going to be our answer. Distributing the 2 in choice C gives me 40k minus 40. All right, that's not the same. So that means that C is probably going to be our answer, but let's double check that D. Distributing the 2 gives me 40k minus 20. So yeah, for sure, our answer is C. Number 5, we've got x cubed minus 7x, and we want to know which one of these is equivalent. Now, this is one where it probably is going to be easier to just factor out the GCF, which is x, and what we can do is divide each one of these terms by x. So x times x squared minus 7 is going to be our answer here. We can see that's answer choice C. But if you're still a little shaky on your GCF factoring and how all that works, you can just approach this problem the same way that we did the last 4, which is just to go ahead and multiply out each answer choice. So because the multiplication here gets a little messy, actually it's not too bad. Let's just do one at a time. So for choice A, I have x minus 7 times x squared minus x. So I'm going to use the distributive property. First, I'm going to distribute the x to get x cubed. X times x squared is x cubed. X times negative x is negative x squared. Then I'm going to distribute the negative 7. So negative 7 times x squared is negative 7x squared. And then negative 7 times negative x is positive 7x. So you can see that this is definitely not going to be the same as the original problem. So A is not going to work out for us. For B, we'll work this out similarly. Distributing the x will give me x cubed plus x then distributing the negative 7 will give me minus 7x squared minus 7. All right, so I have the x cubed minus, oh, I don't even have the 7x here, do I? So yeah, this one's just going to be all kinds of wrong. C, which we already kind of said was the answer, let's go ahead and test it. X times x squared minus 7. I can distribute the x, and I don't have to do any more than that because it's just a monomial times a binomial rather than a binomial times another binomial. And here I get x cubed minus 7x. That is going to be our answer. Oops. It's going to be C, but let's just make sure that we're doing this right. We're going to take our time because the TSIA2 test is untimed. You get as much time as you want, so you might as well take advantage of that. Take your time. Make sure that each question is answered to the best of your ability without time being an excuse here. We get x cubed minus 7x squared. So yeah, this is close, but not right. So yeah, our answer is C for sure. For number 6, we will approach this the same way we approached number 5, where we'll just check each answer choice. So for A, and I don't think I'm going to like rewrite them all like I did up here. I'm just going to go with the answer choices that are given and just try to squeeze in the work here. I'm going to distribute that A, and that's going to be A cubed minus 5A, which actually that looks like that's going to be our answer. But let's check the rest of these. A squared times A would be A cubed. And then A squared times negative 5 is going to be minus 5A squared. So that is not going to be correct. Well, that A squared shouldn't be there. For C, we're going to have to do two sets of the distributive property. A times A squared will be A cubed. A times negative A would be minus A squared. Negative 5 times A squared would be minus 5A squared. And then negative 5 times negative A would be positive 5A. So there's really two issues with this one. First, this should be negative 5A. Look at the problem. And then also, we shouldn't have any quadratic or squared terms in our expression. So yeah, C is not going to be the answer here. Let's try D, although I think we'll have similar luck since we already know the answer is going to be A. But A times A squared would be A cubed. A times 1 is A. Negative 5 times A squared is negative 5A squared. So these two are almost the same. Not quite exactly the same, but pretty close. And then finally, negative 5 times 1 is going to be negative 5. So yeah, this one's just not going to get there either. Number 7 is another problem that's set up basically the same way, and we'll approach it the same way. Distributing that b squared for choice A, b squared times b is b cubed, and b squared times negative 13 is minus 13b squared. That is not what we want, so it can't be A. Distributing the b to both b squared and negative 13 will result in b cubed minus 13b. That is what we want. So yeah, probably going to be B here. But we want to check every answer choice that we got. C, since this is a binomial times a binomial, you're going to want to distribute both terms here. You can also use the box method or the area model to get that done, but I don't think all that's really necessary for this problem. Here we get b cubed minus b squared minus 13b squared, and then plus 13b. That is close. We got the b cubed. That should be a minus 13b. So even without those two quadratic terms, this is still not going to be right. And then for our last choice, b minus 13 times b squared plus 1. If we do b times b squared, that's going to be b cubed. Right? If I do this, distribute that, and then times 1. B times 1 is just b. Negative 13 times b squared, b minus 13b squared. And then finally, negative 13 times 1 is negative 13. So this is not the same either. We can rest assured that B is the answer. Now, for all the problems from here on out, you can still use this strategy that we've used on problems 1 through 7, which is just to go ahead and multiply out the answer choices and see which one is equivalent. But because we spent so much time actually working on factoring, I think I'm going to actually go through the factoring steps here. Now, you can use the distributive property and check each answer choice, but I kind of want to switch it up here. You already know how to do that. We've gone over 7 problems, kind of showing off how that strategy works. Let's actually work this the proper way. Okay, using the big X. So when the leading coefficient is 1 here, these are considered the easier quadratics to factor. Okay, you can use the big X to immediately come up with the constants that are in each binomial. So what we're looking for are two numbers that multiply to give me that constant, negative 12, but have a sum that is negative 4, that linear coefficient. And so if you're having trouble coming up with these terms, just think of the factors of 12. We've got 1 and 12, 2 and 6, 3 and 4, and that's about it. Since it multiplies to negative 12, that means one of the numbers in the pair has to be negative, because a negative times a positive is negative. And if the sum, negative 4, is also negative, that means the larger of the two numbers needs to be the negative one. So we're looking at 1 and negative 12, 2 and negative 6, 3 and negative 4. And the one that adds up to negative 4 is going to be this 2 and negative 6. So that means that our two factors will be x plus 2 and x minus 6. So our answer is D. Number 9 will be solved similarly. We'll use the big X again. Here we're looking for two numbers that multiply to give me negative 10 and add up to negative 3. Once again, if you're having trouble, just go ahead and list all the factors of 10 here. So 1 times 10, 2 times 5, that's it. And since the product is negative and the sum is also negative, that means that one of the two numbers has to be negative, the other one being positive, but also the larger of the two numbers has to be the negative one. So we're either going to have to use 1 and negative 10 or 2 and negative 5, and the one that actually adds up to negative 3 is 2 and negative 5. So the two factors here would be x plus 2 and x minus 5. That'll be C. Number 10, which of the following is equivalent to x squared minus 3x minus 18? We'll be working this out exactly the same way. Really no surprises here. Looking for two numbers that multiply to give me negative 18, but add up to negative 3. We have the same situation where the product is negative and the sum is negative. So as I start to write out all of my factor pairs here, is that it? 1 times 18, 2 times 9, 3 times, I think that's it. We're looking for one of the two numbers to be negative, and for that negative number to be the bigger of the two numbers, since the sum is negative. And so, yeah, the combination that's going to work here is 3 times 6, just like it was 2 times 5 before. The negative number is going to be that 6. It's got to be the bigger of the two numbers, so that when we add those together, we do get the negative 3. So here we've got 3 and negative 6. Our factors are x plus 3 times x minus 6, which corresponds to answer choice A. For number 11, we'll work it out just like the last few problems. Okay, I'll even keep up, maybe I'll keep up that last one just so you can see how the structure of how we work this is the same. We're going to find two numbers that multiply to give me 6 and add up to give you negative 5. Now 6 is kind of a small number, so hopefully you're able to figure out what these two factors need to be. Now, since the product is positive but the sum is negative, that means both numbers need to be negative. A negative times a negative is positive, and that's the only way we're going to get a negative sum. So if we're thinking about the combinations here, there's only two choices here, and that's going to be negative 2 and negative 3. So the two factors for number 11 will be x minus 2 and x minus 3. So the answer is A. Number 12. Which of the following is equivalent to x squared minus 7x minus 8? Same kind of problem here. This is going to be a pretty common item type on the TSIA2. So make sure you know how to work these. This should be an easy question to get correct for you. Okay, we're looking for two numbers that multiply to give me negative 8, add up to negative 7. Our factor pairs for 8 would be 1 and 8, 2 and 4, and that's it. Since the product is negative and so is the sum, we're looking for the bigger of the two numbers to be negative. And so the only combination that works here is 1 and negative 8. So our two factors are x plus 1 and x minus 8. Which one is that? Let's see here. That's going to be choice A again. Wait a minute. Are these all choice A? No? Okay, I just got a string of A's in a row. No problem there. That can happen. Number 13. Okay, this is a similar problem. It's kind of worded a little differently in that they don't actually give you any instructions. They're just saying which one's equal, but it is basically the same problem. So here we're looking for two numbers that multiply to give me 4 and add up to give me -5. The factors for 4, and there's not really too many of these, 1 and 4, 2 and 2. Since the product is positive and the sum is negative, that means they both need to be negative. So the only combination here that'll work is -1 and -4. And as you go through these, there should be only one combination that works. If you find 2, then you're probably doing some of the arithmetic incorrectly. So x minus 1, x minus 4 will be our factors. Now, one thing you might notice here is on the answer choice, the two factors are not written in the same order. Here it's like x minus 4, x minus 1. I had x minus 1 times x minus 4. That is totally okay. Multiplication has this property called commutativity, which states that the order doesn't matter. 2 times 3 is the same as 3 times 2. So yeah, the order of these two binomials does not make a difference at all. Now, number 14 is where it starts to get a little trickier because here we're trying to factor a quadratic trinomial where the leading coefficient is not 1. This is one of those harder quadratics to factor. You can't do it as easy as these other ones we did where you just use the big X and you come up with your answer really just kind of in one step there. Here we're going to use the method that we used in class, which is the X box method. So we're still going to use this X, but just in a different way. All right, we're still going to be playing that game of like find two numbers that multiply to this and add up to that, but where we get those numbers is going to be just slightly different. So to find the number that goes on top here, the number that we're trying to multiply by, that's going to actually be A times C. In other words, the leading coefficient times the constant rather than just the constant. 2 times -12 is -24. And then the middle term is still going to go in that bottom section, 5. Now, before I go any further, I want to get my box set up, which is really just the area model that we talked about in previous lessons. The answer here is going to show up here along the top, and then the other factor will be down here. That's where we're looking for the answers. But let's get this box set up. The first two terms in the two binomials have to multiply to give you that leading term, this 2x squared. So that term is going to go in the top left box, 2x squared. Then the constant is -12. That's going to go in the bottom right square. And then for the other two squares, we're going to get the leading coefficients that add up to 5x by completing this big X game. So we need two numbers that multiply to give me -24 and add up to 5. 24 has quite a few factor pairs, so let's write them down. Also note that the 24 is negative here, so that means that one of the two numbers needs to be negative. Since the sum is positive, in this case, it's the bigger of the two numbers that needs to be the positive number. So the only combination here is going to be -3 and 8. Now, in all the previous problems, we basically got our answer straight from that. But on these problems where the leading coefficient is 1, we're going to use those two numbers as the leading coefficients of the two linear terms that we put in the upper right and lower left boxes. It doesn't matter which one goes where. I'll put -3x here and 8x here. Okay, now time for the magic. We're going to get our solution here by factoring out the GCF of each row and each column. So if we look at the first column, that's this column right here, the GCF of those two terms is x. 2 and 3 do not share a factor pair, but they both have an x, so we can factor that as a GCF. Now let's look at the right-hand column, 8x minus 12. The GCF of those two terms is 4. So I'm going to write plus 4. In other words, 4 is the biggest number that both of those are divisible by. Now, to get the other factor, we've got one of the factors just kind of ready to go here, x plus 4. To get the other factor, we're going to do the same thing, but we're going to be looking at the rows of the area model or the box. So let's look at that first row right here. Both 2 and 8 are divisible by 2. So we'll start with 2, and then both terms have an x, so we're going to have 2x. Now for that last row, that bottom row, notice that we have negative 3x and negative 12. One thing you got to do when you're pulling out these GCFs is if the leading term is negative, you got to pull out a negative number along with it. So the GCF here, we're going to say is negative, since that leading term is negative, 3, since both 3x and 12 are divisible by 3. So that means that my other factor here is 2x minus 3, and that gives me my final answer, which is D. On number 15, we're asked to decide whether or not x minus 1 is a factor of either of these two trinomials. So this is really like a two-parter here. You need to find the factors of both the first quadratic and the second one. We're going to have to factor both of these and just check to see if x minus 1 is one of those factors. So let's start with x squared plus x minus 2. This is a quadratic that has a leading coefficient of 1, so we can work this out using just simply the big X here. We want two numbers that multiply to give me negative 2 and add up to 1. Those are the constant and linear coefficients respectively. The two numbers that will make that happen, that multiply to negative 2 and add up to 1, well, since that product is negative and the sum is positive, that means one of the numbers has to be negative, one of them is positive, and 2 only has two factors, 1 and 2. It is a prime number. So at any rate, this is going to be 2 and negative 1. And so the factors for x squared plus x minus 2 are going to be x plus 2 times x minus 1. So x minus 1 is a factor of that first one, but now we need to check the second one. So 2x squared minus 5x plus 3. This is a quadratic where the leading coefficient is not 1. So we're going to have to use that Xbox method. Or if you know another method, you could use that as well. But that's just the method that we've been going with so far. Definitely see a lot of success with this. I just think it's probably the easiest way to go. So let's go ahead and do that. Pardon me, I'm getting... All right, here we are. Okay, so we'll set up the X, set up the box, put that first term in the top left like we've been doing all along here. The last term goes in the bottom right. Okay, multiply those two coefficients. 2 times 3 is 6, and that is the number we are going to try to multiply to. And then we are going to try to add to that middle term negative 5. So we need two numbers that multiply to give me 6 and add up to negative 5. 6 is positive and 5 is negative here. So we need two negative numbers, and those two numbers can be negative 2 and negative 3. Negative 2 times negative 3 is positive 6. And negative 2 plus negative 3 is negative 5. So those are going to be the coefficients of the two linear terms that I put in the top right and the bottom left boxes. And it doesn't really matter which one goes where. Either way will work. Now we're going to look at the GCF of each column and each row. So that first column, the GCF, and maybe I should highlight this just to be clear. We're looking at this first column here for this area model. We need the GCF of both of these terms, and that's going to be 2x. Then we'll look at the second column. Now, if you say the leading coefficient or the GCF here is 3, I'm definitely empathetic with that, but you got to make sure for this to work that you factor out that negative along with it. Anytime that first term has a negative sign, just try to make it kind of your sort of automatic here. Anytime you see that negative up front, make sure you factor out a negative. So the GCF that we're going to pull out here is actually going to be negative 3. Now, going along the rows, look at the top row here. The GCF here is just going to be x because 2 and 3 don't share a factor. And the On the bottom row, we're going to factor out a -1. 2 and 3 don't share a factor again, and they neither one, 3 doesn't have an x, so we can't pull an x out. So there's really nothing we can pull out except for that -1, since that leading term is negative. So here, the two factors are 2x minus 3 and x minus 1. Notice that both of these two quadratics have x minus 1 as a factor. So yeah, they're both going to be answers here. So our answer here is D. Number 16 says the area of a rectangle is modeled by the function x squared plus 5x plus 6, which expression represents the dimensions of the rectangle. Now, you can work this two ways. You can either try to multiply this out. We've talked about that method. Or you could just go through the factoring process, which I think is going to be a little faster, particularly when that leading coefficient is 1. We couldn't really work backwards on the last problem because we didn't have the other factors, so we couldn't multiply it out. Like we did way up here, where we're actually multiplying out the two polynomials. That you really, for number 15, have to know how to factor. I think that's really the only one where you can't really get away with working backwards. But even when that leading coefficient is 1, you can work backwards and just like multiply out all these answer choices, but the process here is pretty easy, especially compared to when it's not 1. That I think it's just worth it to just go ahead and factor. So we need two numbers that multiply to give me 6 and add up to 5. Those two numbers are going to be 2 and 3, very similar to the last one we just did. So that means our two factors are x plus 2 and x plus 3. Our answer is B. Number 17 says the height of a rocket can be modeled with this quadratic function. Which expression shows this height written in factored form? So just really another factoring problem. And the leading coefficient is 1 again, so we're going to use that big X. We need to find two numbers that multiply to give me -18, but add up to 3. Now, 18 has, that's not prime. It might be worth just kind of writing out all the factors here of 18. 1 times 18, 2 times 9, and 3 times 6. Is that it? Is it divisible by 4? No. Yeah, I think that's it. So since the product is negative and the sum is 3, we need a positive 3. We're going to need one number to be positive, one number to be negative, and the larger of the two numbers to be positive, so that the sum ends up being positive. So really the only combo that's going to work here is going to be -3 and 6. So the factors are x minus 3 and x plus 6. And yeah, the variable is actually t here. So let me go ahead and fix that. Not that that's going to make a huge difference, and you probably will get the problem right anyway. They're not going to try to trick you like that. But yeah, t minus 3 and t plus 6. Our answer here is B. Number 18. We've got a company's profit in dollars can be modeled by this quadratic function. It looks like all these questions are basically the same. Which factored expression represents the profit? So don't get distracted by all the context. It's just asking you to factor this expression. So we'll work it out just like the last two problems. We're looking for two numbers that multiply to give me 12 and add up to 8. The factors of 12 are 1 and 12, 2 and 6, 3 and 4, that's it. And since both the product and the sum are positive, both of these two numbers should be positive, and the only sum that is 8 is 2 and 6. So those are going to be our two constants in the two binomials. Our factors then are going to be x plus 2 and x plus 6. So here the answer is A. Number 19, a car's distance from home is modeled by d equals x squared minus 9. What expression represents the factored form of the distance? There are two ways you could approach this one. One is to recognize that this is a difference of two squares. And if you know your difference of two squares trick, you know that a squared minus b squared is the same thing as a plus b times a minus b. Okay, so in this case, the a would be x and the b would be the square root of 9, which is 3. So our factor is going to be x plus 3 times x minus 3. And you can get the answer really quickly there if you know your difference of two squares. But let's say you didn't. Let's say you forgot that little trick. You can still use the big X to accomplish this. It's just that the number on the bottom is going to be 0. So we're looking for two factors Now multiply to negative 9 but add up to 0. And the reason why it's 0 is because there's no x term here. It's like a 0 plus 0x. So the two numbers here would be plus or minus 3, and we already know what the answer is going to be here. It's going to be x plus 3 times x minus 3, which is what we already knew. But just know that this problem can go a little faster if you know your difference of two squares. If you don't, then you could still use the big X method. And so let's finish off this review with another similar problem here. A rectangular garden's area is given by a equals x squared plus 7x plus 10. What expression shows the area factored? Let's do the big X one last time here with the constant being 10 and the linear coefficient being 7. Two numbers that multiply to give me 10 and add up to 7 would be 5 and 2. So the two factors would be x plus 5 and x plus 2. And that is it for today's review over factoring. As always, please reach out if you have any questions, or if you want me to go into any more detail on any of these problems. I'd be happy to do that. If this big X or even the Xbox method, if they're just really not making sense to you, if you are not seeing success with that method of factoring, let me know, and we can definitely go through some other methods of factoring, like factoring by grouping. And there's a couple other different ways you could do it. I find that this is probably the easiest way, but you might see success in one of the other methods that are out there. Just let me know, and we could definitely go over that. But otherwise, y'all have a great day. I'll see you next time.